My name is Shriram Veerisetti, and I'm a bioinformatics master's student at Boston University. And today I'll be going over my BF 591 R-Shiny application. To begin, I'm going to share my screen and show you all the paper itself. The title is mRNA-seq Expression Profiling of Human Postmortem BA9 Brain Tissue for Huntington's Disease in Neurologically Normal Individuals. The counts matrix, as well as the differential expression matrix, are garnered through the supplemental file section of this website, and those will also be used as inputs for certain tabs within the application. Now, to go over the application, we have the sample information tab, and first we're going to produce a summary of the information. It has your column name, it has your classification, as well as any means for any numerical categories, such as your age of death, RIN, mRNA-seq, as well as age of onset. Here we have a table that the user, me, just inputted, and we have all the different columns, as well as all the respective values and characters if necessary. Next, we're going to go on to the plot. And this is really neat because you're allowed to choose what variable you want on your x-axis. Suppose I want sample RIN, and I'm going to click submit here. It's going to take a second to load, but while that's happening, I ended up choosing two different plots, the histogram plot as well as the density plot. And I think it's very interesting because we are allowed to show the same data in different ways. And these two different ways are very, very beautiful and have very, very different ways of going about it. Now, for both of these, we have your sample RIN on the x-axis, but for the histogram, you have your count on your y-axis, and for your density plot, you have your density on the y-axis. Next, I'm going to go over the counts matrix, and I already have it. I already have the input loaded here because the clustered heat map takes a long time to load. The counts matrix, like I said before, was garnered from the paper itself, and we have two different sliders here. We have one that includes genes with at least X percentile of variance, and another that includes genes with at least X samples that are non-zero. And these two summaries are produced from these different sliders, and it shows you the number of passing, percentage passing, as well as number not passing, as well as the percentage that are not passing. Next, we have diagnostic scatter plots, and these diagnostic scatter plots are very, very beautiful. And one of the challenges I had was finding the variance for every single gene. And the way I ended up doing that was using row bars and appending the variance to a variance column, and that's what's produced here. Green indicates that it did not pass the threshold via the slider, and blue indicates that it did pass the threshold. And same goes for the diagnostic plots tailored to the non-zero input as well. And the median count is located on the x-axis for both. Next, we have your clustered heat map. It has all of the samples on the horizontal axis, as well as count values on the vertical axis. Last but not least, we have the PCA scatter plot. It has the PC1 and PC2 with the 92.86 and 2.62 respectful to whatever PCA plot was plotted. Now we have your differential expression matrix, and the differential expression matrix was garnered for the supplementary file, but the way that the file was produced was by comparing two different variables, one with Huntington's disease and those that do not have Huntington's disease, and DSEC2 was performed. All of the parameters were default except the FDR was less than 0.05, and that was the threshold to be differentially expressed. I'm going to go ahead and load that file in right here. And let's just say I want a different gene. Let's just say I want this gene right here, and I want to plot the log2 fold change on the x-axis. I can go ahead and click submit. You'll only get the gene of interest as well as all of its different columns. And here we have a density plot with the radio button value that the user chooses as the x-axis. Last but not least, we have visualization of individual gene expression. And while I input this, one of the challenges that I faced was trying to find a file that could undergo the sequence of analysis. What I ended up doing was transposing both the counts matrix as well as the sample information and using the merge function to combine them using samples as the rows. So I'm going to go ahead and choose sample neurological diagnosis. I'm going to enter a gene of interest. And voila, I get I can choose 3 different plots. I have a bar plot right here. I have a scattered plot here, and then a bee swarm plot. The y-axis has the gene of interest as well as all of the counts, and the x-axis is going to be the sample neurological diagnosis variable, as well as it's split into those with Huntington's disease and that ones that are neurologically normal, and it's colored scale to give the user a proper view of that distinction. Thank you so much. Have a great day and see you later.